Thank you and good afternoon. My name is Kevin, and I work on the AWS Scientific Computing team. And as such, I have the privilege of helping scientists all over the world use the cloud for their research. But to truly empower researchers, additional steps are often required beyond just offering them the AWS services. And to that end, we have with us today 3 speakers. Rich Mendola, Enterprise CIO at Emory University, will talk about a platform created at Emory to allow researchers to use AWS Cloud Services as part of their research workflows. Kerry Jordan, Director of Assessment and Community Equity at the Carpentrys, an organization dedicated to closing the skills gap for researchers, will talk about teaching them the skills they need to be able to use powerful data and software methods in the cloud. Finally, Lisa Green, Executive Director of the nonprofit organization Data Science for Social Good, will talk about how to bring about collaborative data science. Rich.
All right. Thank you, Kevin. Welcome. Happy to be here. My name is Rich Mendola. I am the Enterprise CIO at Emory University. We are a fairly large institution based in Atlanta, Georgia, have about 16,000 students, and have a very large healthcare enterprise. So I want to try to set the context for you in terms of what our research profile is like, so you can understand why we went about designing this particular AWS offering the way we did. So we do a little bit over $600 million of research every year. That's been growing at a rate far faster than many of our other revenue streams like tuition. The vast majority of that occurs within our health sciences setting. And as you can see from many of the signature research programs that we have, we are often using sensitive data, data that has to comply with standards like HIPAA. So when we thought about designing an offering, that was really one of the foundational principles of if we're going to offer up AWS and mediate it in some way for our faculty, it needs to be very, very secure. So as we took a step back and thought about what are the objectives we want to get out of an offering, kind of what are our guiding principles, the first one was we knew that faculty were already utilizing Amazon Web Services. And they had the experience of maybe plopping down their P card and within a matter of minutes, having a machine image up and running and being productive. And we didn't want to take that agility away from them. So we thought long and hard about how do we preserve that. The second thing we wanted to do was really tie them into the Emory administrative ecosystem and not make that feel like a burden. So instead of them having to use a procurement card, we wanted to directly integrate to our financial accounting system so they could use the account codes on their grants to pay for these services. We wanted to tie into our authentication mechanisms so they'd have single sign-on and didn't have another set of credentials to have to worry about. And then we wanted to build it all into a service desk workflow, kind of a one-place shop where they could go and we could walk them through the process of setting all this up. And then finally, we wanted to make sure that whatever we did, as I pointed out, accommodated the requirements for working with sensitive data. When we set out to design this, really all the major parties from IT were involved. So from day one, we had our Chief Information Security Officer, who's here today, my deputy CIO who runs the research IT portion of the organization, and a number of individuals in our IT architecture group who already had a deep experience with AWS and were helping to set up the technical aspects of the design. In addition to getting feedback from the various IT parts of the organization, we worked with a number of our researchers in a couple of key areas before we had any special features in place, just to see how they were already using the Amazon Web Services environment, and to determine were they finding value in it, and how did we need to build it out in a way that they were still going to perceive that there was value. If you're gonna mediate a function, you really need to make sure you're adding value, because in today's era, if you're a mediator and you're not, you're just overhead, and nobody's too happy about that. So we kept coming back to, what's the value, what's the balancing act between making it streamlined, but at the same time making it secure. So because we were going to change some of the very fundamentals of how you interact with AWS, we decided that we were going to rebuild the entire landing page. So for those that are used to going to the AWS landing page, this should look very familiar. It's patterned very much after the standard offering. But what's different about this is a couple of key things. When you click on the button in the upper right-hand corner to create your account or VPC, it's not taking you through the wizards with Amazon. You're coming into our system and you're going through our workflow. We created a special app, which I'll talk about in a moment, the VPCP console, for managing the parameters of once you set up your environment, what are your firewall rules, et cetera. And we've taken all the text and really customized it to the specific Emory offering. So AWS has somewhere between 120 and 140 high-level services. We, out of the gate, are only going to be supporting a subset of that, so about 50 of those. So we wanted to make sure the documentation and all the narrative reflected the fact that this was really our customized offering. So let's dive a little bit into the detail, or at least as much detail as a CIO can go. This is really where a lot of the action starts. We built a ServiceNow form, that's our service desk, to walk the investigator through the initial workflow. And it starts by asking them some fairly straightforward questions. Are you going to be doing HIPAA compliant research or not? What's your billing code that you want this charged to? What's your user account name at Emory that it'll be linked to? And one of the things we set about, and this is a really important piece of this initiative, we knew that if we accepted our status quo practices in trying to offer up this service, we probably weren't going to be successful. When we started this project, the reactions we would get from some of the technology teams were, we need to set up some firewall rules. Well, that's fine. Submit a manual request. We'll have those for you in a day. Here we need to set up an account. That's another day. By the time you added all of those things together, you're looking at a 5-day turnaround. What in a manually driven process might not seem so bad for any one thing, it would be a death blow to a service offering like this, where somebody's used to being up and running within a matter of minutes. And so we really pushed the teams to say, you might not think this is automatable, but we're going to find a way to automate it. And we took about 48, at this point, 48 and counting, because we're still finding a few things, 48 steps, and we got that down to about an 8-minute duration. We were targeting about 10 minutes as our bar, where we thought that would be a pleasant experience for the faculty member or investigator. And really proud of this. We've done some online demos where just literally click the button and you can watch it all playing out behind the scenes, and to see what for so many years had been taking us so long happen so quickly. We're really proud of that change. Those diagrams you see off on the right were just the type of VPC environment that they would want to use. So do you want to keep all the traffic self-contained within the Emory environment, or do you want to expose it to the internet? That was one of the other whys in the road that they were asked to make a decision on. The virtual private cloud provisioning custom app was our single pane of glass. So once you're in the environment and you've created a VPC, how do you manage the parameters associated with that? So things like, I want to designate my postdoc to be an administrator on this account. I need a new firewall rule. What rules are already in place that I've created? What are my sitter ranges going to be on the network side? How do I maintain my elastic IP environments? Again, we really pushed the envelope here and ended up I think, coming up with some benefits that I'm not sure we fully realized going into the project. So for example, in our on-premise environment, if you ask for a firewall rule, went through a process and you got that request approved or denied. The next time you went to ask it, if it was a year later, you would have to track down, what do I already have in place, how to figure out where to keep that information. Here, everything associated with your environment is in one place, so it really makes it quite convenient. This is one of the more important pieces of what we set out to do, and the original hope was that we were going to be able to put all the necessary security controls in place using as many Amazon native approaches as possible. And of course, we're using some of the identity and access management functionality to set permissions. We're using service control policies, so if we haven't gone through the process of certifying a service yet and exposing it to the institution, we're simply going to shut off the service and say it's not available. So the way this works is for every service, our security team goes through a review, and you can see some of the tasks and literally our attempt at doing some activity-based costing on what each one of those steps would cost from an effort and dollars standpoint. But for each major AWS service offering, we do an assessment. We determine, is it a service that needs to be blocked or not? If we're going to make it available, what security policies do we need to instantiate on that particular service? What that ultimately meant was, in this third point, we needed to create a set of security risk detectors and controls to put in a place associated with each one of these. So a very simple one would be, if you're in a HIPAA environment, we're never going to allow you to create an S3 bucket that's not encrypted, right? And they get more sophisticated. So there's some of the database offerings you're allowed to use for HIPAA, others you're not. And so we were able to do that on a service level basis. It's real important to understand that number there, the $8,000, is an average number, and that's per service. So we're going live in August-ish, and we're going live with 50 services. So in general, it costs us about $400,000 to certify all those and create this offering. A couple other important attributes of the offering. We try, as you might expect in a university setting, to steer as much with carrots rather than sticks. So we've procured an AWS Enterprise Support Plan. Anybody that signs up for using our mediated access to the product gets access to that plan. We've got the BAA signed in place, ready to go for HIPAA-compliant research. We spent a good bit of time related to the security theme, also making sure we had an approach to custom keys private keys that prevented individuals from getting in trouble. We had seen some examples of maybe not so thoughtful behavior with private keys before, when folks were just using their credit cards and putting them in places that weren't really secure, and bad things happened. So we spent a lot of time thinking about key management and how that was going to work. One of the other really important lessons learned for folks was on the networking side. We expected when we went into this project that we were going to be using a direct connect model into the AWS regions. And what we found was a limitation there that for our set of use cases really were going to prevent us from doing that. In a direct connect model, you're limited to 50 virtual VPCs, virtual sessions per direct connect. You can get around that with the direct connect gateway, but it only works on an individual account. And we needed it to work on, we're going to have hundreds of researchers accessing this. And so that was a wall we had to work around, and decided to go a VPN route instead. For those that are interested, the whole model of what we did was built on a service-oriented architecture. We realized that not everybody's going to have the same service desk, the same financial accounting system, the same identity management system as us, but the architecture was really built to say we can pull one of those out and put a different one in, and that's not going to be that hard. We used a lot of Java, web services, Python, and PyTest for some of the testing. Given the costs that are associated with this, one of the things we're trying to do within the higher ed community right now is to build a consortial effort so that other universities join us in continuing to expand the number of services that have been certified and offered with AWS, and potentially even to take this to other cloud providers as well, knowing that we're going to get pressure eventually to have the full complement of services across all the providers. And we've had some real good feedback as we've brought people in under the covers and showed them the code and how it actually works in reality. So we're going to be doing some more work on that in the fall. So with that, I will turn it over to our next speaker. We can hold questions till the end. Yeah. Great.
All right. That was fantastic. Let's keep the party going, shall we? So good afternoon, everyone, and thank you so much for allowing me to be here. This is my first time at Amazon Web Services Public Sector Summit, so it's truly been a pleasure so far. My name is Kerry Jordan. I'm the Director of Assessment and Community Equity for the Carpentries, and we are a nonprofit of 11 that empowers about 1,100 member community who teach data skills for free. And so what I want to do today is kind of talk to you about how we're able to self-sustain our workforce training programs and how we're able to leverage the services that AWS offers. In terms of biomedical and other research, we understand that we live in research data fields that are extremely heavy and that we require sophisticated tools and computational resources. Unfortunately, today's tools of choice for many researchers is the humble spreadsheet. So I want to pause and ask you, how many of you have had a spreadsheet nightmare? Okay, tell the truth. Most researchers leverage spreadsheets for everything from data catalogs to experimental design and tracking and analysis. As useful as they are, spreadsheets just are not often up to the task needed by the researcher, and they're prone to introducing errors such as automatic data formatting and unexpected sorting results. There's a better way, and there are better tools that are available for researchers today, including statistical programs like R and Python. The problem with these sophisticated tools, however, is the training that's intended in order to use these tools and make them successful in your own daily workflows. Neither you or I have enough time to learn a new tool. How many of you have a month, 2 months, a semester of free time to learn something new to apply to your work? I saw no hands go up. Oh my goodness. So there's just a better way. Software and data carpentry, this is where we come in. We are formed of teams of researchers, and we teach foundational computation and data science skills that are needed for researchers through short, impactful 2-day workshops. The model that we follow is to train the trainer, where we certify volunteer instructors who empower communities of local impact on their own. In this way, we're able to scale beyond our 11-member staff. We've leveraged Amazon Web Services to streamline lab and classroom setup and to make our lessons reproducible. So what I want to focus on for the next couple of minutes is how we've been able to make our approach sustainable for the research communities that we serve, and how Amazon Web Services help support our mission to help researchers get more done in less time and with less pain. So let's talk a little bit about, I keep saying this word sustainable. What do we mean by a sustainable program and leveraging sustainability? We know that we live in a data generation. We are generating tons of data even as I speak right now in this room. Vast amounts of data are being generated from social media sites to water meter readings in our home to even the Lyft and Uber driver Every single day, we're generating data. The value, however, is not in the information and the knowledge that we obtain from the data, not just the data itself, but what can we do turning that data into resources and solutions to solve problems that are important to us. For a sustainable data management and analysis workflow, we have to have the infrastructure that's strong enough to support this data so that we can use it to address problems that we're either passionate about or that you're voluntold to solve. It's about turning a sea of data into discovery and solutions. So, picture your typical research plan. Yes, it does not take a year. Maybe it could take a year, but it never takes a year. Let's consider the overall workflow. You begin by identifying a problem. This normally comes from hopefully something that you're passionate about. You move to defining the problem succinctly and then designing an experiment, testing your hypothesized solutions, and then after the assessment of the alternative solutions, you select one, you execute the intervention, and hopefully evaluate the outcomes. Now, I made this look really nice and really just straightforward, but we know this is not reality. Where do you think in this process the problems that researchers have the most? It's in this design, this assessment, and the evaluation portion. You've collected mounds and mounds of data, and now you need a strategic workflow to analyze this data and turn it into solutions and resources. The issue that we face is the lack of people with the skills, perspectives, and access to work with data efficiently to turn this sea of data into discovery and solutions. So this is where the Carpentries comes in. The Carpentries, or Software and Data Carpentry, we're a global community teaching foundational computation and data science skills to researchers in academia, in industry, and in government. Software Carpentry's curriculum focuses on the basic lab skills and scientific computing, and Data Carpentry's curriculum focuses on the skills and tools that are useful to work more effectively with data. I'm very proud of this. Since 2012, we've increased our yearly offering of workshops from 38 to 337 across the globe. And now we're reaching more than 7,000 learners per year. In terms of our reach, our instructors live all over the world. We've even had a workshop that took place in Antarctica. I was not there, but I know it happened, and they said it was fantastic. So here's another snapshot of some of the workshops that go on all over the world. And just for example, last week I was in Addis Ababa, Ethiopia, teaching 23 in the Train the Trainer program, teaching instructors so that they can teach these workshops in Kenya, Namibia, and in Uganda. So I keep talking about these workshops. What exactly is a workshop? How do we operate? What does it look like? We teach 2-day high-impact workshops. We understand that people are more engaged when they're with their peers, and so we ask for you to bring a friend or a colleague along with you to help you learn the skills and offer some peer-to-peer interaction. Our quality lessons are practical with practical applications and offer hands-on learning. All of our lessons are free and available online through a Creative Commons license. Our trained instructors focus on conveying understanding, not just demonstration. We're a community of peer learning and seated among local attendees who are in a broad international community. We also promote a culture of openness and of sharing. We want you to interact with us and with our lessons and even contribute to our lessons. We have lessons in genomics, in ecology, in social sciences. There are people who are starting lessons in astrology, in astronomy. So we're always looking for new domains to add to our lesson stack. We believe that in becoming a carpentry instructor, you are also becoming a community of practice of like-minded volunteers. So is what we do really helpful? Is it impactful? Does it work? I always like to talk about our impact because this is specifically what my role is in assessment of whether or not our workshops have an impact on our learners. What we've done is designed pre and post workshop surveys. We want to measure, of course self-reported, the skills and perspectives that learners have before and after the 2-day workshop. And we've also designed a long-term assessment to understand what impact have we had a year out from the workshop. Are learners still using the tools? Has their confidence increased? Has their self-efficacy increased? And what we've noticed is, comparing the pre and the post workshop score, we're seeing in some cases a full 1-point increase in mean. For example, being able to write a program that can solve a problem in their research, being more confident in their programming abilities, and being able to overcome a problem if they get stuck in a programming language using R or Python. So we're finding that the 2-day short, impactful workshops, each workshop is 2 days, 8 hours a day, they're having a strong and a lasting impact on our learners. So I want to focus specifically at how AWS has helped support this Carpentry's mission and our vision to help researchers get more done in less time and with less pain. Focusing specifically on our data carpentry lessons, we've incorporated cloud computing with AWS into our curriculum through our Genomics lesson. We all know, we've heard it throughout the keynote, throughout the first presentation today, it's no longer possible to analyze genomic data on personal computers. Any bioinformatics workflow needs to incorporate remote computing. We chose to teach Amazon AWS because it is broadly available and is already being used extensively in bioinformatics. So what you see here is the learning objectives for the Introduction to Cloud Computing workshop that is taught within data carpentry. More specifically, this is the workshop page, including the lesson and overview of the objectives and the setup instructions for each learner in the workshop. In terms of our overall teaching platform, we have an AMI of the instance that we use to teach the workshop. And that includes the data set, the bioinformatics tools, and even the exercise solutions. With the support from Amazon Credits for Research, we are able to spin up an instance for everyone in a workshop that they can use during the workshop. And each student has the same paths, environment, and workflow. In this way, we're able to remove any ambiguity and frustration, especially about varying paths, permissions, and operating systems. We're able to focus on the important aspects of learning without the cognitive overhead of having a different setup for each student. So we're very proud that AWS has allowed us to do that and reach so many learners. I want to bring it home with this idea of bringing people to data to solve problems that they're interested in and that they're passionate about. How do you think in your own work you can do something as significant as we're trying to do at the Carpentries? What skills and perspectives can you bring to this sort of problem? We want for researchers to have the skills and the perspectives to access data to address the options and the problems that are significant to them. We do that by empowering individuals to reach their full potential to solve issues in scholarship and society. People talk about bringing data to compute or compute to data. We want to bring people to data, and we appreciate what we've been able to do with Amazon Web Services to help us scale up our training program and allow us to reach so many people and help them to be able to collect, analyze, and interpret their data. AWS's remote computing platform provides us the ability to offer computational access as well as a teaching platform. Overall, a key part of democratizing data is democratizing compute. Remote and cloud computing makes that possible, and we are very proud of how we've been able to leverage AWS to sustain our workforce. So with that being said, we have one more speaker. I would love to hear from you more if we have time for questions at the end, and then we can certainly figure out how you can become involved with the Carpentries. Thank you so much.
Hi, my name's Lisa Green. You might have been expecting to see Rayid Ghani here today. Unfortunately, Rayid's plane was delayed, and then delayed, and then delayed, and then canceled, so he couldn't be here in time. I work with Rayid on the things we're going to talk about today, and so I'm filling in for him. My background is in physical sciences, and for the last several years I've been working in the data space, primarily in data for good. Rayid's background is a lot more impressive. He has 15 plus years of leading data analytics research teams in the private sector, chief data scientist for Obama for America, founded the Center for Data Science and Public Policy at the University of Chicago. Oh, I'm so sorry. It's just the title slide that we missed. Founded the Center for Data Science and Public Policy at the University of Chicago, and most recently created this program. The Data Science for Social Good Summer Fellowship. So you could say that we're both data do-gooders. And working with programs like this, there's probably another dozen that operate on this same approach, this same method, that you bring together a group of people, some with technological skills, some with social good projects, and in a finite amount of, or in a defined amount of time, in usually the same location, you have the skills of the first group applied to the projects of the second group. It's great. There's lots of impact that come out of that. But it's not sufficient. And we both knew that from working with programs like this and with this specific program. So recently, Rayid and I started building a new nonprofit that we call Data Science for Social Good, without the fellowship. At its core, it is an online marketplace for matching people with machine learning and data science and other data-intensive work skills with projects from social good orgs, nonprofits, NGOs, government agencies. In the reasoning, apologies. I apologize for the white text, but I think we can still read it. Hopefully, I'll read it to you. The first motivation, the first benefit we hope to get out of this is that the public sector wants machine learning. Or maybe I should say more machine learning. There are pockets within the public sector of technologically sophisticated organizations that are leveraging machine learning, but most nonprofits and NGOs and government agencies don't have a team of data scientists. May I have a show of hands? Who here in their organization has a team of machine learning experts? Okay. Who here would like to have a team of machine learning experts working on your machine learning? Oh, wait, for free. More hands now? Can I get more? Okay, right? So the public sector needs these skills. The private sector is certainly leveraging machine learning to massively increase their profits and get a competitive edge. But think what we could do for the benefit of society if we brought that power, again for free, to the work of groups that are working toward socially beneficial projects. And at the same time, machine learning experts want meaningful work. There's a well-known quote from Jeff Hammerbacher. He's one of the founders of Cloudera. And it says, "The best minds of my generation are figuring out how to make people click ads." That sucks, right? people, they have these tools, they have these skills, and they're doing maybe mundane or tedious work or not something that inspires them. And that is a significant need. And we see it all over with programs like the Summer Fellowship and the others of that style, with hackathons, and just the general desire to have work that matters, that's meaningful and fulfilling. And then everyone wants to close the skills gap. We heard from Kari about how important that is, and we all know that gap, right? There's more demand for people with these skills than people who have these skills. And then after you get trained by data carpentry, what better way to really enhance that, drive home that training and enhance that training than to work on real world problems with real world data, and ideally in a collaborative team, because that's usually how data science gets done in the real world. So this is why we want to build this. This is the motivation and the benefits that we see. But it's not enough to just do programs like the Summer Fellowship. And again, there are a dozen others. And we've all seen the hackathons to cure cancer and things like that. To which I say, imagine trying to build Wikipedia through a series of hackathons, most of which don't know about each other. Would that work? So to really have an impact, to really scale this, it needs to be on the cloud. And that's what we're building. And of course, it's built on AWS. Of course, it's built on AWS. Being built on AWS means it's in the cloud. It means that anyone, anywhere can contribute, can participate. Now we're talking about a scale. Now we're talking about a global community that brings an increased diversity of domain expertise and data methods. And there's a lot of services and capabilities within AWS that allow us to have this sustainable global online community working toward this. But I want to call it one in specific, Amazon SageMaker. Who here is familiar with Amazon SageMaker? A fair number, but okay, for the rest of you, this is your homework. Go and do a search, either on the AWS site or just on a web search. This is AWS and SageMaker. It's an amazing service. It's a machine learning service. And this is, there are Jupyter notebooks within it. There are optimized algorithms. I'm not going to spend the next 20 minutes telling you how great SageMaker is. It's well documented on Amazon. But this is what allows us to be really sustainable, because we have a system of record now. Instead of doing these projects and like handing off the results to a social good organization, they live on in this online, in this cloud, and they're reproducible. And this is really sustainable. I think my timer is close to frozen, so the last thing I'm going to leave you with is that I'm excited to say that we're launching in August of 2018, less than 2 months away. I'm kind of surprised there's not at least one exclamation mark up there. I'm very excited about this. And we are actively seeking, if your organization has a project that you would like to see a team of free data scientists working on, get in touch with us. This is the website of our program at the University of Chicago. Also, who has the app? In the app, you can just put in Lisa Green. That's my name, and then you can find me on the Summit app and contact me there. And if you're interested in volunteering, maybe you've been through a data carpentries program recently, or maybe you're an experienced professional, but you want to learn a new skill, something that you want to practice, we're also taking volunteers right now. And as far as the launch, we're working closely with AWS. And if you're in the AWS community, if you're in the flow of news and you read the newsletters and the blog posts and things, you will hear about it. We're hoping to speak at one of the summits or maybe reInvent, but we'll definitely be working with Educate and many open data sets. That's another great AWS program. Who knows about that? Ooh, that is way too few hands. That's your second piece of homework. So 1, go look up SageMaker, and 2, look up Registry of Open Data on AWS. And that's it. Thank you very much.
Thank you very much to each of our 3 excellent speakers. Could I ask IT to perhaps go back to the first slide in the presentation that lists the names of the 3 speakers? And with that, I would like to open it to the audience. We have a generous amount of time left, so you can pepper and grill our 3 speakers with any questions that are dear to your heart. And I'm staring into a glaring lamp, so don't be too subtle about it.
I have a question for the first speaker. So did you re-implement all the AWS services, call them separately out of your own menus and with the same fonts and styles and stuff to make it look like AWS?
Yeah, no, we actually haven't re-implemented any of the services. We've just, yeah. So we've just front-ended them and.
Doesn't that risk, when they evolve new services, you had to constantly keep up with them? Why don't you use something like AWS Organizations to sort of integrate more tightly into their more tighter coupling?
We do use AWS Organizations extensively in the design, but we sort of reach a limit in terms of the capabilities of what we're able to do at a pretty granular level. And I agree with your point of the risk of creating new entry points into the services. We break wizards. I mean, there are issues we'd prefer not to do, but we felt in order to get an appropriately secure offering, we had no choice but to go down that path. We're working closely with AWS, and our hope is that we get out of this business to the greatest possible extent. Of if they're constantly rolling out new features. A few were just announced today that may hold some promise to take over some of the elements of some of the functionality that we've built. But we would love nothing more than to not have to do this.
Hi, my name is Tim Loomis. I have a question for Lisa Green. Hi. How are you going to do evaluation for all of this free data science that you're going to get from volunteers, who most of them are probably under 30 at this point because of their education levels, who really need to be paid, who already are going to have biases coming in to use your resources to get the answer that they've already predetermined? How are you going to go about that?
So I heard a few questions in there. One was, how are you going to evaluate the quality of the work afterward, right? So when I say that this is an online marketplace to match volunteer data scientists with social good projects, it's a vast oversimplification. You could actually break that into many buckets in the volunteer side. One of the most important being scoping. Data science people can't always scope a data science project, and then QA. So this is a community of volunteers. It's significantly large now, even in private beta, at thousands. We're adding more in July. This should bring us over 10,000. So there are people who will be assigned QA, not unlike. And then the next question was, I think, or maybe it wasn't a direct question, but something about the bias that people bring in. They have an idea about the answer, right? Or at the very least, they bring in, hey, math and programming is here to save you all. We know best, right? There's a few things about that. One is that when I say that a global community not only increases the number, but the diversity of people and the approaches, their domain expertise, the techniques that they would use, there's that it's collaborative, and that we're not dealing with, let's say, a group of students from one particular university or a group of volunteers from one particular large tech company. So the diversity, I think, helps with bias. The scoping will help when people define the approach. That is not the case, that 2 or 3 people get to determine the approach and then set off on the path. And there was something else I think about the jobs, and they need to be paid. This idea is not that people take a 2-3 month sabbatical from work to work on it. That's the way most of these are done now. This is something that you do asynchronously in your own time, more like an open source software project through Apache or something. So they will be being paid. Many of them are getting paid very, very well. This is something they want to do in their spare time because they're bored of actuarial tables and predicting insurance rates. Does that answer?
This is a question for Rich Mendola. Rich, wondering if you're going to use any other standard other than HIPAA, such as like FedRAMP, first part of the question. And second, how are you planning on managing compliance as you add data to your current database?
Yeah, good questions. So I think in terms of standards that we'll need to support, that's primarily going to be driven through demands that we see from our research community. And so, FISMA is another standard that we need to work towards. It's a little higher bar, has some additional constraints, and so I anticipate that we will be sort of continuing to raise that bar and try to meet other needs. And the second piece of the question was?
The second piece of the question is how do you handle ongoing compliance as you add data to your current database?
Yeah.
In other words, you can be compliant today, but as soon as you add data to it, you're out of compliance. How are you going to manage that?
Yeah. I think it's a dilemma that's probably no different than how you manage it on-prem right now. I mean, we have investigators distributed all over the campus. We're very non-hierarchical organizations, and we do the best we can to help them make sure they're not getting into trouble as they load particular types of data and deal with having patient data in this environment. And we anticipate we will have patient data in this environment very, very shortly, identified patient data. Some of that will be managing centrally at scale. Some of it's going to be in pockets with individual investigators. We'll give them best practices. We'll build machine images for them. We'll do all the hand-holding we can. But ultimately, there's no way in a distributed, large-scale university you can ever guarantee 100% that you as a central entity are going to be able to prevent something bad from happening with an individual investigator, unfortunately.
This question was for Dr. Jordan. Could you talk just a little bit more about how you used AWS to make your lessons or workshops repeatable?
Yes, so come forward into the light. Step into the light, Caroline. So all of our lessons are hosted on GitHub right now, and so all of our lessons are collaboratively. We have a couple of maintainers per lesson and a lot of community input. So we have lesson developers for each of our lessons who come together and in the same way do hackathons and bug barbecues to create the lessons, develop the learning objectives, develop the challenge questions, and then host all of the lessons using our template on GitHub. And I just want to say, you can see all of I spoke a lot about the genomics lesson specifically because that's what we use that's why we use AWS, but we also have lessons in version control, in R, Python, SQL, and others. So if you have more questions or want to see more of the lessons, you can just go to datacarpentry.org and you'll find all of our lessons there.
I will make one quick point. So a question was raised about compliance around, ongoing compliance around data. The talk in the session before this session on genomics in the cloud actually addressed some of those points, and so I'd encourage you to look up that talk. All the talks at this conference will be made publicly available. And then, one more comment? Yeah. Yes.
So one of the questions I had is in regards to, and it could be for any of the people who were on the session, typically we hear about moving to the cloud, like lifting and shifting is not the most efficient way of doing it. So as people are moving their research to the cloud, are they changing what they're using to do the research? Are they moving from SPSS? Are they moving to the Python? Or is already familiar to a lot of people, I think, but are they, is that maybe because of its nature, it's a good cloud option? So that's are people changing what they're using, some of the research tools and techniques that they're using once you move into the cloud as well?
Sure. Good question. We just had a session yesterday at Emory Research IT Day where that very issue came up, and one of the constraints was the way we've licensed some of our products now, SAS and SPSS. We're not allowed to use them in this environment, so we're going to have to go back and renegotiate those licenses because the current terms don't allow it. So there's already been this movement to R because of a variety of benefits. We're seeing a lot more R usage coming out of the gate. Open source works well for many of those use cases, but I think we're gonna have to go back, and I think it'll be interesting to see how some of the vendors in that space react to these new environments, because some of the licensing models just really don't work in infinitely scalable AWS environment.
Is there any some of the AWS tools that are there? Some of their like the redshift, like all the
Yeah.
people moving to that?
Sure, and so the question was, what about AWS specific tools? I mean, where we can take advantage of those, we love to take advantage of those. We're trying to definitely move in that direction, both for some of the central things we do, as well as encouraging our customer base as well.
And I just want to echo that specifically for the Carpentries. Personally, I had to move from using SPSS to, well, actually on the first day of work, they said, do you want to use R or Python? And I had not heard of either. And so I said R. I have no idea why. And so, but our mission is that the tools and perspectives will be accessible to everyone. So we reach out to a lot of communities in South and Western Africa, and they don't have licenses to MATLAB and SPSS and things like that. And so that's why we choose the more open source tools that are available.
And with that, we are at our time limit. So you're welcome to come up and meet our speakers in person if you like. But I hereby close the session and thank you for your time.